Thank you all for being here. I will make a short introduction just who Cyril is. Cyril is an internship student coming from France to our lab. I will not say much. Cyril will present Synthea, a mechanism to create synthetic data. Cyril, take the lead.
Okay, so yeah, as Pantelis said, is a tool used to create synthetic data. So I'm going to talk about a little bit the background of this project. So Synthea is a project that was created by doctors, scientific, and also with the help of the government. So this tool was created to build synthetic data to be used for study and to run scientific study to say this to run scientific studies and also to prevent people to. I'm sorry. Let me break it down. So Synthea is a tool that was created by doctors, scientific, and also the help of the government to create synthetic data because the data in the hospital can't be used like that. We have to have the agreement of the patient to have this data. So that's cause a little bit trouble. So that's why they create synthetic data, Synthea, that can create synthetic data and also synthetic data and anonymous. So I'm going to show you how the three pillars of the Synthea. So the first pillar of Synthea is the module. So the module are different graphs that are stored in a JSON file that represent the medical journey of a patient. So every node in this graph represents a medical event, like a diagnostic or a consultation, or also maybe an hospitalization also of the patient. And so in this graph, the age I weighted by probabilities. So maybe if you are old and you have a high BMI, you most likely could have diabetes. So also another pillar of this project is the demographic data they are gathering. So those demographic data help the model to be realistic and to don't have wrong information. Basically, if there are 20% of people in Paris that have COVID-19, those data will be stored in the demographic data, and that will the Synthea tool will try to create a scenario where around 20% of the population have this disease. And all of this is carried by a probabilistic model that help to weight the different probability in the graph. So, here I have created a little graph, if I can say that, not really a graph, but it's a tree to for you to understand how those state graph are used. So we have different cases. Here we have the data of a female who was 52 years old. We have BMI of 32 and who don't smoke. Who don't smoke. So the information are stored and are used to create they are used to weight the probability of the age. So this person can most likely can have diabetic or not, and if he have a specific treatment for this diabetes. So that's a really simple view of what graph in Synthea look like. I can't really put a real graph in this slide because it was too big and that was not fitting on my on the canvas. So also so also Synthea have many different output type. The most used is those two output type, HL7 fear and bulk fear. The first one is widely used in States and also in France. I don't know if you know Dr. Lib. I think it's a French, no? Okay. So each patient is stored in a JSON. And in this JSON, there are many data. There is the hospital where there was a hospital is where they have their consultation. Also, different condition if this person was in school or have a medical health background. But this data is really complex and also expensive in storage. So does not the best format to apply analysis. So that's why they create bulk fear, another type of output that are most optimized for big data. For example, I created 100 patients in bulk fear that was around 1 MO of storage. But in the regular fear, it was 371 MO. So also in Synthea, there is a lot of parameters. The first and maybe not the most important, but it's population. We can also design the age range, the state, and the gender. Also, we can decide if the patient should have if all the patients should die or not. And we can also set the medical history of the patient. Basically, this means the patient will have 10 years of medical history. And we can also select which disease we want to have. But I think the most simple is to show you how it works. So I have, oh, so let's see, I think I have to, okay, I think I will share. I'm going to share my terminal. So, so that's okay. So for example, if I want to create one patient, I will run this command and see. So it's really fast. Not really fast. So now we have our patient created. So his name is Mikkel. So you can see she is 54 years old. and she's a male. Wait, I will show you the JSON that wait. Okay, so if I should go there. I I I don't I can show you the JSON, but I have another way. Tu vois pas? Non, mais enfin, I have a problem. When I share my screen, I can't really click on share. Yeah. Okay. Okay. Okay, okay. Okay, so okay, so yeah, okay, 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 perfect. Thank you to Julian. And so non, so j'ai toujours le même problème, mec. Je peux pas. C'est quoi le problème? Quand je clique, tu vois, euh, c'est comme ça. So I'm going to show you on Firefox. That should be better. So that's the patient. That's not the right patient, but that's another patient I created before. So we have different information in this JSON. We have different diagnostic. That I don't know why, but that should show you the exact information in the red line. But I don't know if you see my mouse, not my mouse, yeah. But, so I don't know why, but
I don't see your mouse, but if I understand correctly, this is a web application depicting the data created
yeah,
by Synthea, right?
yes, the pixels, the data created by Synthea, and that show us exactly what happened in this particular moment. But I don't know why that don't work really fine. But yeah, yeah.
Okay,
I don't
regardless of the technical issues that might prevent you from showing different things, various things. If I understand correctly, Synthia also provides this web application, right?
no, that Synthea was not providing this application. That's an application that online no online developer created on Git to simplify the visualization of Synthia data.
Okay. I have some questions. I don't know if your technical issues would allow you to show us. If I understand correctly, one of the first slides that you showed us, there are modules, there are demographics,
Yeah.
and there are
Yeah. So the modules are the disease, the different disease. For example, there is a module named flu, and that contains different type of flu. So you can choose a specific module like flu, but if you only pick flu, that will create different kind of flu. But you can select a specific flu also.
okay. So you select some of or all the available modules,
Yeah.
and the data set created through the command line as you showed us, contains patients along these profiles, okay?
No, the command I run is I run. I don't know if you saw my no, that's not true. But the command I run, that was only one patient, and I don't have specified ill or
Okay,
um
so
any
so somehow, but at least in principle, even though you might not have shown this to us, I could in principle run a line of code which would use these modules.
yeah.
Okay. Can you please show us how these modules are defined? Is there some kind of a configuration file for this module?
Yes, there was stored in JSON. I can show you the rough representation of these modules if you can, if you would like.
Would you please show us an example of how these JSON files are used to configure a module?
Okay, um, I'm going to show you Synthea. So that's a JSON file that store a module name. Enfin, what this module name is allergic of rhinitis.
Okay, this is
So
allergic rhinitis.
okay,
Okay, so it only defines the conditions for a specific patient, right? For specific diagnosis, for example.
yes, yes. There's on this module there are different events that can different event that are the node of the graph, and there was also probabilities where so you can pass a different node. So yeah,
Okay.
but I can show.
I can see that you define some distributions, giving some probabilities on whether the patient, a random patient would have this or not.
Yeah.
Okay.
But if you want, I can show you a graph representation of this JSON, but they are really big, so I don't know.
No, it's fine. What I can see now answers my question. So you can build the profile of your patients and define the specific probabilities for each condition
Yeah.
that you might care about.
Yeah, those probability was calculated by using statistical model, but also you can change them like that on the JSON. For example, for the COVID-19, they use Synthea to simulate a pandemic a pandemic uh, a pandemic issue. So they just change the probability directly in the JSON.
Okay.
Uh,
And I guess that there are also similar configuration files for demographics, for example, right?
yes. The demographic data are only available in not only available, but in the project I download, there was only for United States, but you can upload your demographic data. For example, if I have the demographic data of the Greece, I can upload them on the CSV for simulate Greece demographic uh, environment. So
Okay. I also have some other questions, but guys, the rest of the team, feel free to jump in. Cyril, unless Cyril, you would like to show us also something else.
uh, I I
Do you
would
have anything else to show us?
uh,
Do you have
I,
anything else planned?
I wanted to show us how the JSON, the CSV file of the demographic were stored, but I'm trying to fix some issue with share screen to show you.
Okay,
But
please proceed. Please proceed, and then I will ask some questions.
but you can ask. I will try to
Okay,
to
I can ask in the meantime, I guess.
yeah.
I have seen that you have told us that there is a way to export the synthetic data in a file format, in bulk file. I don't know what bulk file is, but there is a flavor of file. I wonder if there is a way to produce OMOP-CDM data.
Yeah, exactly. So the build data, the formal build I talked you about, there are ETL process that already has been created to transform Synthea data in Oxygen data.
Okay, so if I export my data in bulk file, then there is a script to convert this to OMOP-CDM.
Yeah.
But this is an external script.
Yes, that's not built by Synthea. There are some
Okay, it's not.
genius people in the internet that created the script. Mm,
I also have another question.
Please proceed.
Is there a way to produce a data set looking like another data set? So, for example, if I have a real data set from a real hospital,
Yeah.
is there a way to tell Cynthia, take this real data set, learn the distributions of the diagnosis, learn the distributions of the demographics, and then produce a synthetic data set following the same distributions like the real one? Is there a way to do that?
I think so. What you want to do is to take a real data set about of one hospital and reproduce the same demographic information and also medical events uh, to create more data about this specific hospital.
I would like to create a data set, a synthetic data set, which would look like the real one, but not exactly the same. Because as you understand, I don't want to use the raw data set
Yeah,
because of
I
privacy.
I think this is possible because in Synthia you can adjust everything. If you you want to work on a specific disease or ill that Synthia don't have, you can import your JSON, and you can also change the demographic information. So I think how to do that is take the real dataset from the hospital, um, um, reproduce the demographic information about the real one, not reproduce, but I mean,
Learn.
yes, not really learning, but I mean, you have to retrieve the information, like the demographic information, the address, and I don't know how to say it in English, but
Age or yeah,
yeah,
this kind of stuff, or zip code.
yes, you can take all the information and tell Synthia that's how I want my dataset to be. So I think it's totally possible
Okay.
because I can change the demographic information that's Synthia base yourself.
I was thinking that perhaps there was a module based on machine learning or whatever, which could be trained to learn the demographic information automatically so that I wouldn't have to do that manually.
Yeah, I don't know if there are such algorithm created, but I think we can definitely do it manually.
Okay. Guys, these are all my questions. I don't know if the rest of the team has something to ask.
I have a question or to add to what you said earlier. From what I understand it, it uses disease profiles. It doesn't use demographics uh, in general. So I'm guessing you probably cannot replicate the entire dataset of a hospital, of a real-world database, because many of the variables are irrelevant to, meaning, if you, I don't know, if you broke your leg and your dataset have also data about diabetes or your blood pressure, probably the disease profiles would not have that information that you also have in your database.
I was thinking that perhaps this machine learning tool that I had in mind would learn the disease profiles and the variables from your dataset.
I'm sorry, I don't fully understand what you said.
What I said,
Yes.
or what Padel said.
Sorry, I don't understand. I don't hear there was a noise.
Can you hear me now?
Yes, yes.
Okay. I thought I understand what Achilles said. Achilles said that Padeli Synthea uses disease profiles to generate data.
Yeah.
So you have to have a disease profile, and your real data set might not be compatible with the variables defined in this disease profile. Right, Achilles? This is what you mean?
Not only compatible in the sense that there might be variables that don't exist in your data set, but also your data set have many more information which you would like to be in your synthetic data set, but are not related to any disease.
Oh yeah, I understand.
Yes,
But yeah,
but this data could be considered demographics, I guess.
I am.
don't.
There are measurements, I am guessing, or observation, meaning how your blood pressure is or your fever is, that are not relevant in all diseases, meaning it
Yes,
doesn't matter. You understand what I'm saying?
yes,
So if you want, so if you
it,
want, if I may, so if you want to make a data set that is, what to say, completely comparable to your raw data set, you have to create uh, all the conditions you found in your data set.
so
This is why I thought that it would be a good idea not to depend the creation of your dataset on a specific disease. Because indeed, you are right, Achille, and I don't see any real need to do that, to depend your data, because the datasets are there and they are not built. The real data are not really created based on disease profiles. Real data are created based on everything. I mean, a patient coming to a hospital could have everything, could have anything.
Yes, but I think the idea behind Synthea is that your data will be synthetic, but also be useful. Because if you make a synthetic data set with the distribution of all your patients, you might end up with data that don't make sense. Meaning a patient that's suffering from, I don't know, rhabdomyolysis, has a very low the indication.
I was supposing, perhaps I'm wrong, that the clever module would understand that a patient diagnosed with rhabdomyolysis should also have a high distribution of CPK. Do you know what I mean? Because the clever module would see the association between the two variables.
There are
This is what I
millions,
mean. This is
not
what
millions,
Sorry?
billions. I mean, you know, relationships between
Yes, there are. Yes,
variables.
there are. Yes, of course, there are. Of course, there are numberless potential associations. You're totally right. Yes. Yes, perhaps it's not feasible. I don't know. I don't know. I really don't know. I just thought I should ask. Perhaps what I'm saying does not make sense.
If I fully understand what Achilles said, is that sometimes the medical profile of a patient from the hospital could maybe not say making sense in Achilles, but can be random, can have every type of association that maybe is not true in Synthea modulus.
I'm not really sure I understood what you said, Cyril.
So what I was saying is that maybe in the hospital there are high variability of combination of disease that Synthea can't reproduce.
Okay. So you agree with the idea that Synthea produces a dataset based on specific disease profiles, right?
But I'm not sure to understand what you are saying by specific disease profile. So when you say
Could you please show us again the configuration file?
yes, okay, that's
Achille, probably you are right. The potential associations, the potential statistical associations are too
okay.
many.
So your things
So you see here that, for example,
yeah.
when somebody has allergic rhinitis, he might also have seasonal allergic rhinitis,
Yeah.
which is a conditional onset, okay, which means that a seasonal allergic rhinitis, I guess, is only possible if the patient has allergic rhinitis, right? And it says that there is also somewhere to another condition has been, for example, here you have a distribution of 0.4 for has perennial and seasonal allergic rhinitis, right?
Yeah.
Or distribution 0.2 for the, on the upper part of the screen for the transition on has seasonal allergic rhinitis. This distribution value of 0.2, I thought that could be learned if I used a real dataset. If I had a real dataset with patients of all kinds, some of them would have allergic rhinitis, they would have the diagnosis, and some of them would have also the diagnosis of has seasonal allergic rhinitis, right?
Yeah.
And I guess that the association between the two conditions would be 0.2, and this could be calculated.
So what you are saying is that can we take a real data set and recalculate the probability on the distribution?
Yes, at least I thought that this could be possible.
I think
Perhaps it's too difficult to run it in a real dataset, in a big real dataset with millions of patients. Perhaps it would be too computationally expensive. But if, in principle, if you have like 1,000 patients dataset, a real dataset with 1,000 patients with 10 diagnoses, then it should be doable. Achille, do you still disagree?
No, I agree, and I don't believe the number of patients is the problem. I believe the
The
problem
number
is
of variables is the problem.
yes.
Yes,
If you say I want to measure 10 conditions and 50 variables, it probably will be possible. But then
I agree.
your dataset will not be an exact replica of your the initial, it will be
It would be similar.
similar
It would follow the same distributions at least.
for only the select the condition. But
Yes.
then again, for meaning for a specific research, meaning probably you have a specific research question, it will be enough.
I don't think it's enough. I don't think that synthetic data can really be the solution, because when you create your synthetic dataset, you inherently add a bias, because you have to select the variables that you want to calculate the distributions upon. So the people designing the synthetic dataset, they introduce a very specific bias. So I don't think that synthetic datasets are really a solution. They are a solution if you want to play around and prepare your analysis, perhaps, and then, but still you would need to run your analysis on the real data, if you ask me. I don't know, Calliope, if you have seen anything else being discussed on the Synthea project, on the Synthea IHI project that we work on.
No, I'm not attending the work packages that are for synthetic data generation, so no idea so far.
Alexandre, do you have anything to add on that?
No, but I think yeah, it's quite hard to really replicate what you have like to see. I mean, that's the whole point of the project, right? Of Synthia. So it's not easy to, because I'm looking at the modules here and then I'm seeing that they're calling all these sub-modules and all this stuff. So it's very, I think maybe that's what they're selling here, not that's what they're giving you. They're giving you like a model for data generation. So that's what they are selling, not like you can create a model from your own data. That's a bit,
Perhaps
I think it's much harder, I think.
okay, yes, perhaps it's not there yet. I'm not really sure if what I'm suggesting is out there or not. But I understand that Synthia practically sells a default mechanism, a default distribution between well-known conditions, so that you could twist a little bit if you would like to play around something, and then create a data set that you could test your algorithms against. I guess if what I suggest was really out there, we would already know, and it would be widely used, right?
So if you want, I can show you the graph representation of the JSON if you like.
Yes, if you can share it, yes, of course, why not?
Yeah. So that's the representation of the JSON of one of the JSON file. I'm sorry, I think I can't zoom. So I can't.
This is a disease module, right?
Yes.
For chronic kidney disease, probably chronic kidney disease, obviously.
Yeah.
Okay. So this is the big thing that they gave to community, Alex, huh? the doctor, they provided the expertise on how how the doctors would expect real data to look like for each
Yeah.
condition. Which is, of course, a very valuable contribution.
Yes, so they have predefined what is it like condition progression paths, right? And then they have probability. It's not just the probabilities. That's the easy part, I guess. The hard part is to define all these paths.
Yes,
So-
because the way that they did it, and this would be the hardest thing to mine out of the database, would be the time associations, the timely associations between the various events, not only the probabilities, right? This is what you have in mind, Alex?
Yes, yeah, exactly.
The patient path, the patient's progression path.
Yes, and then because I was looking at another one, and then they also have treatment modules. At some point, there is like a treatment decision, and then you go to another module, and then so it's a lot more complex.
Yes.
Yeah.
Than
So-
just adding random diagnosis. It's a lot more complex than just adding random diagnosis. Eh? Okay. Yes, indeed, this is very interesting. And you can twist that. This is very important. Great.
And also, there is many parameters you can change on your query on Synthea. I can show you the file where all those parameters are stored. I don't know if it's really relevant. If you want to, I can. I'm not sure. If you want to see.
Yes, Cyril, show us what you think is relevant. We don't really know what could be relevant or not. We are just exploring here and really discussing.
Okay. So that's the whole with you can really create your dataset with different information. So as I said, you can choose the output type. I'm going to go up to it. I haven't tried all the parameters because they are really a lot. So as I said, you can also have hospital information about which hospital take care of which patient. Also the practitioner, what doctor, where did she work with, etc. The different output you can have. Also the demographic information I was talking about. You can also, yeah, that's here. That will give you geography. You can select a specific state, a specific city, and also a specific zip code. For example, if I want to have only a patient from a certain zip code in a certain group, in certain state in US, I can have that. Also, you can also I haven't used those parameters yet, but you can select the not a social score, but in this right here, you can select what should influence more if the patient is a good place. For example, here the education is really important. the income is less important, but you can play around with those parameters. Also, I know there was parameter for the birth date. You can select a specific birthday for your patient, and many more parameters. I don't know if you have question about this. And
It's,
also,
it's I think it was a very useful discussion for me. Alexander, you have also had the synthetic data set that you used to play with. Could you please remind me its name? I am also aware of SynPath beyond Synthea.
No. So for the Dragon project, we wanted to have some synthetic data, and it's actually one generated from this Synthea
Okay. So
data set, but it's a bit cleaned up. I think they cleaned it up and they threw away like some patients that were like, I don't know, but it was a bit modified. But the
Okay.
base was Synthea, yeah.
Okay, so your synthetic data set was also built using Synthia. I can also see the SynPath. I am wandering around the internet as we speak. I have seen that Synthia was created by an American organization, by a US-based organization. Actually, this organization goes many decades back, but it's not a health-specific organization. So Synthia is one of its open source projects, but it has many other projects. And I can also see that SynPath is also created in the United States, but SynPath aims to emulate insurance claims, not healthcare, not hospital data. Okay. Great, guys. If you don't have anything else to ask, I have finished my questions. Thank you very much, Cyril.
thank you for listening to me. And, yeah.
Thank you.